Good evening, everyone. Thank you for coming. My great pleasure to introduce you to two people you might know already. But so Scott Batty, who I think I probably must have known for about 20 years. So big core part of the technical teaching team here for that long. Runs a fantastic thing called the Site Diary, and also teaching in a third year and MArch. And a great mixture of technical and design knowledge. Urna, who was a student here, and she is now teaching here, splitting her time between teaching and practice. And so it's very nice, always great to welcome back a student who's talking here, but just really nice to work with you. And it's nice that the two of you can talk about sort of two aspects of retrofit, or kind of connected bits of it, from two different perspectives. But so thanks so much for agreeing to do this. Thank you. And Urna says she's nervous, but I don't believe her, so don't be nervous.
Do I just start? Okay. Good evening, everyone. So this lecture is by myself and Scott Batty, and our work and interest in retrofit. I would like to start by defining retrofit. It's the act of fitting new systems designed for high efficiency and low energy consumption to buildings previously built without them. This diagram by Brandt breaks down the layers of change that happens to a building. Retrofit commonly sits in the space plan, services and skin that I've highlighted in the red box. To share my own personal interest into the specialization, I reflect back to why I studied architecture, and this is the Mongolian gear, which is better known as the yurt. This is a photo I took in my grandma's province in Mongolia, which is called Sukhbatar. You can see it is a home for a young herding family with minimal stuff, light integration with the earth, and they have utilized every part of the gear. The Mongolian gear is made with low embodied carbon, and its manufacture is supported by the livestock and resource that surrounds it. The design, construction, and longevity is sustained by a circular economy when it is used as a nomadic home. It is easy to disassemble, move, and reassemble in a matter of hours without any tools or fixings, ideal for nomadic living. But also in terms of maintenance, it is easy to repair, reconfigure, and reuse. My family still uses my great-grandfather's original gear, which has been repainted and re-insulated, but it has lasted for 4 generations. This initial understanding and interest of the gear led to a series of studies and models. Here is a photograph of Scott Batty in my BA model for technical studies called A Personal Gear, which was in 2016. I had the idea to further minimize the structure of the Mongolian gear by creating a modular panel system, but then with bamboo and canvas. But then I realized bell tents kind of do that already. But going back to the Mongolian gear, it's the concept of the circular economy that sustains the architecture, which is now for 2,000 plus years. A circular economy aims to design out waste. Waste does not exist. Products are designed and optimized for a circle and for a cycle of disassembly and reuse. The dwellers of the Gir herd livestock, whom provide them with food and material for everyday life, wool for clothing and insulation, leather for shoes, ropes, saddles, and originally the skin of the Girs. They also provided transport and entertainment, now replaced by cars. Here is a nomadic home on custodial land and free roaming livestock. Today, the Mongolian Gir has been used as a home for settling in the capital city, Ulaanbaatar. This stagnant use of the structure fights against the earlier described qualities and requires retrofitting. The photo of nomads who have migrated and settled in the capital city. Reasons for migration are employment, education, and encouragement by the state. But a concerning issue was the environmental effects of climate change, which caused environmental seasons of Zood, which is when the winter is so cold all the livestock dies, and families would be left bankrupt because their livelihood and all their seasonal reliance of resource would die. Rural Urban Framework is a research and design practice in Hong Kong. They've made some interesting prototypes to combat the issues of the Gir faced in the city, which relate to heating, electricity, sanitation, access to water, and security. The success of it is questionable, but it reminds me of glamping, but just not as pretty. I have aimed to use the qualities of the Gir to better implement low-carbon methodologies in the built environment, especially in retrofit. The Mongolian Gir has been slowly refurbished over the centuries. Refurbishment is a process of improvement by cleaning, decorating, and re-equipping. It may include elements of retrofitting. This is a photo of the Gir in the 17th and 18th centuries. The skin is made from hides, and it has no chimney to control the fire smoke. Post-Soviet industrialization and capitalism, it is covered in canvas, it has a metal chimney, and it acquires electricity through a solar panel. I thought this displayed how retrofitting and refurbishment works together well. Two recent examples of retrofit that I think is really successful is this project in Basel, which has retrofitted an old wine warehouse. As you can see, it looked like quite a mess before, but now it is now affordable housing. And Chart Street Studios by Ian Chalk in London. So retrofitting, refurbishment, renovation and restoration can resolve urban challenges and constraints of existing architecture. It works with what has occurred. It does not erase, but adds upon what was already there. In practice, I have worked on two key projects. One called 210 Pentonville Road in King's Cross with Hut Architecture, who Scott Batty who co-founded, and 45 Whitfield Street with DMFK Architects. This building was built in 2009 and had this kind of green tone to the glass and blue insets into the glass, which became quite outdated. But to work with the existing building and bring it back to modern aesthetic, we kind of owned the blue tone and grounded it with design and covered the green glazing at the bottom with mirrors as a light touch refurbishment, and used the blue to kind of lead the design of the refurbishment. 45 Whitfield Street is another project, a brutalist building from the 1970s, and it was refurbished in 2009. Some of the metal facade is replaced with back-painted fenestration. Derwent London are a big property developer, and they were the client, and DMFK were the architects where I used to work. Like the previous project, our approach was to work with the existing qualities like the lozenge windows and the timber window reveals. And this is of it complete on site. The key things I learnt to consider when working in practice with existing buildings was, are we providing spaces of well-being, and that related to standards like well and neighbours? Are we improving daylight and sunlight consideration, and how is the building constructed and maintained? As you can see here, the internal design looked to work with the existing structure and not use any toxic or harmful materials. If we go back to the Mongolian gear, it is all made from natural materials and constructed without any tools or fixings, and this was always the approach that I've had. We kept it warm with a natural finish, using mostly timber and stainless steel, and making use of outdoor amenity spaces. On the left, you can see the original timber reveals of the lozenge windows, and to any new portals we created, like demise doors or entrances, we carried on the same language, so that hopefully we can reduce the years where it would be retrofit or refurbished. There are many things within commercial retrofitting that I think have the opportunity to lead with financial strength. Because it's commercial, you have a lot of money or financial strength to lead the industry, to break norms of construction waste and set up systems and procedures of quality standards, especially in strip outs. Can we better control where waste goes? How can we reduce the strip out and recycle more, if not everything? On 45, we recycled all the WCs and T-points, some of them going to homeless shelters who are about to spend £7,000 on a new T-point. So with this specialisation, post-qualifying as an architect, and my interest in retrofit and the circular economy, I now work as a design manager in commercial retrofitting, and I hope to better understand the construction industry, the link between designers and builders, and to share this knowledge. Key areas of my role lies in reducing risk in construction. This includes informed calculations of material for design, for when we order materials to reduce material waste, and knowing when to attain information from the design team at specific timeframes to reduce construction mistakes, which should reduce material waste. And that leads on to what is the future of retrofit. So the company I work with is very interested in recycling and auditing site strip outs. So my director here uses these diagrams and methodologies, where you can see at the bottom it says unacceptable, going to landfill. So she does an audit of everything that's in a building, from all the floor finishes, and if we recycle, how many tons of CO2 we save, the types of recycling route it goes on, like closed loop recycling or in situ. And this helps everyone on the team, especially the client. Within commercial, they always want to be leading in saying that they have low carbon statistics. And here you can see that lighting is the most likely to go to landfill, which is not very good. So that's kind of where all of this has led me to. But moving on to why does retrofit work, which Scott Batty will talk about.
Thank you. From the Mongolian plains to English suburbia, and from a very professional and systematic approach to retrofit to something much more DIY. So, UK, anywhere and everywhere. We built more houses in the late 60s and early 70s than we have done at any time in our recent future, and we have done since. So we can say quite a large proportion, a big chunk of our 23 million dwellings in the UK are of that age, and we know the largest proportion of that chunk is a detached house or bungalow. So that's quite interesting already. I think the question of, how do we retrofit a Georgian or Victorian terrace? How's it going to look? In a way, yes, it's the right question, but it's not the only question. A big proportion of the UK housing stock is post-war and of a particular type. And we've got to get a move on. It's 1.5 homes per minute for the next 30 years. I mean, that is terrifying, especially as we don't seem to be jumping into it. Now, we do know, we've got lots of information, lots of data, not necessarily found by me, but on UK detached houses, annual energy use, the biggest single chunk, this big slice, is nearly 2/3 is space heating. So radiators in the home, keeping us warm. So I'm going to talk about this one house a lot. This isn't the pattern for retrofit in the UK. This is just my house, my project. I'm just going to talk a bit about what I've done, but it certainly doesn't address everything. But I have learnt some useful lessons. So here we go. 1970s suburbia. A plot. This is north is straight up. Naughty, I haven't got North Point on there. There it is. And there's the neighbour. So we have literally got hundreds and thousands of these in the UK, on the edge, ringing around our towns and cities. And this was it when we moved in. So a living room being used as a formal dining room, a tiny kind of dine-in kitchen here, lounge. This was extended out the back, and a nice garden that you kind of see, but not fully. Upstairs, very tiny bedroom, and then views into this garden with this nice tree here. That was the back of it when we bought it. So this is a more recent extension, this box, and the 1970s house is there with the tiles on. So retrofit lessons I've learnt. Understand the typology. So in this case, this was the vision. Late 1960s, early 70s, here we go. A new way of living. Fantastic size homes, detached. Big emphasis on garages, as you can see. Big emphasis on cars. Big emphasis on men. No women shown in this. Guy polishing his Cadillac down there or whatever. But this was completely fresh and new, this vision for housing. Big plots, but there's other things here going on here. Kind of a box, two-story box with a pitched roof, yes. No real overhangs on the eaves to the sides. Limited glazing on the sides. A kind of the flat roof garage or garages as a box added on, and then a kind of emphasis horizontally of something of elements here, kind of locking the two together, and then some brise soleil here. But you'd be lucky if that was facing the right direction, because there wasn't an understanding of that. It was just a kind of stylistic thing. And then different materials in a panel, inset, often inset. There you go. So really, a lot like that. Okay, so the more we looked into this, I think there's maybe 3 million detached post-war modern houses of this period. So box-like forms, 2 stories in height, large windows areas of glazing, particularly on the ground floor to the rear, a differentiated first floor, which has a different cladding, so either timber or hanging tiles, and then this cantilevered or expressed open frame running between ground floor and first floor that kind of wraps around and does something. An adjoining garage, and then often a kind of porch, which again was a new idea, the entrance porch, as a box attached onto this other box. And it's amazing, the more I looked at this, how this particular language just ran through many of the houses of this period. And in terms of building technology, they were all pretty standard as well. So prefabricated roof trusses were just becoming available, so that was new. So they sat onto cavity walls. Cavity walls were new. There wasn't insulation in the cavity at that point. There might have been a bit of insulation in the loft. No ground floor insulation, but there would be a polythene vapor barrier. Remember, plastics were just coming out. And then the windows were big, which was good. You know, this was all the modernism. Big windows, and often in aluminium, so very thin frames, which were great. Not always double glazed, but not UPVC, that's for sure. And another peculiar thing, the windows were always flush with the brickwork. They weren't, you know, so these stylistic things, okay, they could call them stylistic, but when you've got 3 million of these, they become a big deal. And that's pretty much what we had in this property when we bought it, but we liked it. We saw it and we liked it. It made us smile. These windows, these random windows, they've been replaced. They're not the original ones. And you can see it's tired, so that was 50 years old. But it's got this box at the front, added on with the porch. Okay, so this is the ground floor plan as we think it was built. So you've got the main box, the add-on porch, another box out here, which is the garage. It was extended in the 80s, so garage extended forward. This was built on the back. This is what we proposed, so not really extending, just working with what we'd got. We didn't want to obliterate or erase the original house. I think that's important for retrofit. But we wanted to do much more with the space we got, such as this space here, an infill extension. So this becomes a multi-use space here. But then in the ground floor, lots of opening up and axes and views through. So creating a flexible plan that can be closed off in winter and opened up in summer. So on the first floor, this is as it was built, and this is what we proposed. So we were just extending at first floor this orange rectangle, so hardly anything at all, just extending this small bedroom at the front and just kind of rationalising that. This is quite interesting. 50 years ago, when those houses were built, our idea of cold was different to what it is now. You can see there it's changed from 12 degrees to between 17 and 23 degrees. So what does that tell us? Well, it probably tells us we were doing more activity back then, more sitting now in a house, and this has a huge impact on our energy consumption, especially as we know that the bulk of it for residential use is for space heating. This is quite good. So if we kept active, we would. You could do the hoovering in your underpants, and you'd be comfortable at a lower temperature than if you're just sitting doing nothing. Again, has a big bearing on things. I mean, it sounds silly, but just putting on a jumper or something over the top rather than putting the heating on can make an enormous difference when you multiply that by 3 million. Okay, so on this project, we thought a lot about the details. First, yes, aesthetic considerations, but why not? Also, insulation, how a kind of new skin can drop onto the house. How can we get insulation into the existing? How do we insulate? How do we get a continuous line? We could have done, but we would have had to move out to get a completely continuous orange line wrapping all the way around. And we didn't move out, so we were there for the whole time. So also we had these fantastic original floors which we wanted to keep. Okay, we also, as I mentioned early on, yes, brise soleil was being used by architects in the 70s, but it had nothing to do with the sun. It was just a kind of feature. So in this case, south is down here. How could we, without demolishing, how can we exploit the orientation on this project? So could there be a kind of buffer zone on one side that started to do something to contribute to the internal environment? Okay, and the other bit, this is my favourite bit of the project. So instead of lots of CAD or even BIM, this was a kind of analog BIM, and that was it. So because I was living there, I was able to do all of these the night before. Then the next morning, builders come in and look, let's have a look at this. What are we doing today? What are you doing? Let's go through this together. So this was continuously changed and hung in different parts of the house, and then we'd go with the builders and have a chat. And it was like this analog DIY BIM model that was the house became, and this was really effective and exciting. So every morning the builders kind of cursed because there were new things up on the wall in a different place, but actually, they got used to it. Okay, so this is it finished. Well, when I say finished, not really. New skin, as you can see, over the top. We kept the brickwork. Remember, we didn't want to obliterate it completely. We wanted the existing house from the 70s, which we liked, to be recognisable underneath this, and I think it is. Yeah. So these photos are 5 years old. So we're due another shoot. So all of this has changed now and been clad. but you can see this framework, this idea of the framework wrapping around and linking the different boxes together. There's the back, so it wraps around, comes around the back. This is inside, so that view where I said you can't really see the garden, this is it now, so you can see the garden and the tree. These are the existing roof joists, so we kept those, just took the plasterboard off and we turned that into a warm roof by insulating on top. Yep, I think I've actually got the same t-shirt on. I just realised. Yes, so there's that structure. Again, all this has changed, so do another photo shoot. There's the extended bedroom with the 1 metre extension. So the smallest room has the benefit of this, and this is really good for ventilating the whole house through this, because this opens up and you've got this, all of these slats to ventilate it. That's opened up now, so existing kitchen units all in here, clad, overclad, back-to-back sliding doors. Remember this idea of being able to open everything up in summer when you want the air circulating round, but close everything down in winter. You know, in the UK, summer and winter are very different. You know, we wanted to be able to work with that, and that aspect of it works very well. So there was an existing fireplace. We've connected to that. So this is our in winter, and when it gets colder. So at the moment we close these doors down and all congregate in here, which is a good way of getting to see your teenage kids, because the rest of the house is much cooler. So there's the space over the front porch. So instead of that little box on the front, we've built on top of that and glazed on top of it, and then we get the benefit of any heat circulating back through. This is the existing window, so that any heat can circulate back into the house. Some breeze sill on the back, so again using that structure, that framework, that open framework. A fence with leftovers from the house, and a pond with some fish in it. That's very 70s. And there it is. So next door still hasn't been touched, but there you go. Right, so and this is exactly what you want for a Thursday night. I'm going to go into detail about my gas bills. No, it's a bit more exciting than that. I worked with a master's student on the Architecture and Environmental Design course who did a thesis on this. So she built a model of it, a digital model, and she did various tests. So she tested different scenarios. There we are in orange. And she estimated a 61% reduction in energy consumption for space heating, and she estimated 41% of that was from the better insulation and 20% was from better glazing and windows. And then I was able, because I'm living there, this is a study of my energy bills before we moved in, 2 years. That's when the retrofit took place, and then these are 2 years afterwards. So you can see that the gas consumption has gone down considerably. Electricity has pretty much stayed the same. And this is compared with an average UK house here. So if we just look at space heating, I estimate that we saved 60% in terms of energy used for space heating by carrying out this retrofit. Now comparing that with targets in industry, this is us here. So UK average house. Now passive house and Letty, they say we should be at 15 kilowatts per hour per metre squared per year. I'm at double that, but so it's not quite passive house and Letty targets, but it's getting there. And if we compare it with Letty, we are there for space heating at 32 kilowatts per metre squared per year. We're not there overall when you factor in electricity use as well, but we're getting close. So Letty, some of you will know it. The rest of you have a look. Fantastic set of documents with targets for what we're aiming at. This is just a retrofit database, so with a series of different projects of pre-retrofit emissions, post-retrofit shown in blue, and then my project plotted there. So about halfway between those. What we've saved in embodied carbon, we think, maybe 80 tons of CO2 if you'd built a brand new house instead, if you demolished it and rebuilt a new one. I asked students to do this, so I did it myself for my own project. So, some green, but some scope for improvement as well. So I think the most heartening figure, especially for me, is the cost. So just over £1,000 per metre squared, which is pretty good. If I compare that with other projects I've worked on, it's the lowest by a long way. Even lower than this one here. But look, I mean, these will be even higher now. This was done, 5 years ago? They'll be way up into the, getting close to, 9 or 10 grand per metre squared. So where could this lead? These are some interesting images of retrofitted houses, how they could be. This is a nice project done by some students in Holland, retrofitting an existing house with a skin. This is a very nice project in Japan with just adding an extra metre depth to an existing house and using that space, so this space here, in different ways to add and increase the flexibility of the house and improve the environmental performance as well. So here's a few sketches. So take it back to the UK, exists standard 1960s and 1970s construction, and we know it is standard. It's exactly what we had in our house, and this is a very typical case. So cavity wall, roof truss on it, a bit of insulation, tiles, hanging tiles. So we could insulate, add a layer of insulation around the whole thing. We could also add extra depth, so like a buffer zone, this extra metre or so. And then we could start to use that as a space that moderates the existing property. So in plan, remember, we don't know what orientation our 3 million 1970s houses are, so we need something that could be applicable to all. So the sun space could be on the front, this extra skin, and we could insulate the whole thing, kind of wrap it up as like a Christmas present. At first floor, you've got the possibility, as we did in my project, of even with a 1 metre extension of extending certain rooms, but mainly this could be like an environmental buffer zone that takes advantage of passive heating, passive cooling to contribute to the house. If the house is positioned anywhere of this other 180 degrees, this would be on the back of the house. You could still create a draft lobby at the front, which is really essential if we are looking at reducing our escaping heat and our energy for space heating. And so, working with existing houses, we could enhance all of the passive and natural operational principles through spring and autumn. Winter, close it off. Still got radiators on, but not as much. And then in summer, we want to open everything up and maximise natural ventilation. So, in other words, a house, a retrofitted house, you know, it has an operating manual for the people living in it, and they are encouraged to operate it in certain ways, different times of the year, which could be. I mean, I find that I really enjoy doing that, but living in a house could become a much more active thing. Oh, these are some comments had about my house from various people when the scaffolding came down. The favourite one was at the bottom. A man knocked on the door and congratulated us, and he said he walks past every day with his dog, and it makes him feel happy. So that's as important as the gas bills, isn't it? And we mustn't forget that, and this is why we as architects and designers, we need to be involved in this. It's not just about gas bills. It can't be. I'm worried that it will be, but there's no sustainability without beauty. And so I think. Can you go back one? Yes. Mm-hmm. Yep. So I think that our definition of what is ugly now needs to change, and our definition of what is beautiful needs to change. So ugly is wasteful. Anything that is wasteful is ugly. And we mustn't forget the most important bit in the middle of the retrofit. Okay, thank you. That's it.
Thank you, Scott and Urna, for a really kind of inspiring and uplifting talk. So my question is, I guess, from a kind of position of ignorance in the subject area. I was wondering about what your view is on the relationship between retrofit as a genre within the building industry and a set of design approaches and regenerative architectural practice. The idea of emulating living and natural systems, and whether there's a kind of compatibility or there's an intersection or boundary between the two. So anyway, it's an open question. So I wondered what your thoughts were.
Shall I go first?
Yep.
Yes, I think one of the issues I'm really interested in is how can we make retrofit more regenerative, and that's to kind of create a more circular economy around where the material and the resource comes from and the energy and where the waste goes, and having a better a procedure within larger cities in how that can relate to each other more. In the last 2 to 3 years, maybe even the last year, the development in upcycling, recycling, reuse has completely changed, especially within commercial industry. And even small things like when the site is set up and everything is temporary, construction sites now recycle and reuse a lot of old material from other sites, and contractors now share all of that material, whereas before they would buy new every time a site was set up. So like in every element of when a building is being built, whether it's new, whether it's being retrofit, I think finding circularity can help architecture become and retrofit become more regenerative. So then waste becomes something that doesn't really exist anymore. And there's companies now building programs where you have the whole material library of a building that's built in a file. So then when or if it's no longer in use or needed, all of that material, all the doors, all the windows can be taken and put in another new building so that it doesn't go to landfill, it doesn't get demolished. So in that sense, that's kind of how I see it could be becoming more regenerative. I don't know what your thoughts are, Scott.
Yeah, hopefully I've understood you, Samir, but I don't think there's any boundary between retrofit and the use of natural materials. Not architecturally. I think, if we go back to UK residential retrofit, I think the boundaries might be to do with perception, and we are dealing with millions of families living in houses, but it's when you start to think about, I'll just go back to that image, I don't know, doing something like this to all of our homes, that's a huge step for homeowners, and I don't know. It's I just wonder, how people, this might be a UK thing. Would they need to know? They need a certainty of knowing certain materials, I think, and this is the big issue, I think, in kind of dealing with typical homeowners and what how we're going to roll this out. I don't know if that, maybe answers the question.
Sorry, just to come back, I thought, no, really, really useful, thank you. Just a comment, my interpretation of all the discourse on regenerative architecture is that it focuses on new and complex building systems, and the kind of projects that you've shown today, relate to a kind of poetic everydayness, a real kind of intimacy in the way new and old existing materials and structures come together, which is equally as valid as the most complex systems that are proposed as falling under this kind of emerging genre of regenerative architecture. And I just thought it was kind of very interesting.
Yeah.
And I appreciate the comment about circularity as well, Urna, and somehow being able to measure that as well. So thank you, anyway.
Oh, hi. Hi, Scott. I've got a really kind of boring techie question. It's to do with a lot of the decisions that you're making are kind of swinging on the kind of qualitative, and there's been an increasing move towards quantitative thinking around energy consumption and heat loss. And obviously when you're working on a project, you're making perhaps emotive decisions about things. I just wonder, you said you had someone looking at your energy, the energy side of things, whether that was a discussion that you had, or you already kind of made lots of decisions about keeping the floor or keeping this, that and the other. Whether it was part of the design process or whether it was the testing of a qualitative design outcome.
Yeah, it wasn't as embedded in the design process as it could have been. To have a pure process of run the calculations on every material choice or every decision, no, it wasn't. But the quantitative aspects have come, me analysing my gas and electricity bills. We had the model, the digital model, Yes, but that wasn't right from the off, but actually it should be, it could be, it needs to be. But, you know, it's a tricky brief. It's a tricky brief, a family home, and living in it all the time, paying for it. I mean, that's almost an impossible brief before you start. So really my approach was very broad stroke early on. So don't extend, insulate, flexibility, winter operation different to summer. It was really those principles. And I think, you know, as architects, we're always balancing the broad strokes. We've got to bear the broad strokes in mind, and then the micro of the data. And somehow we've got to find a way of moving between both those. Because I think sometimes if you're just looking at data, it's very difficult to move ahead design-wise. But equally, you know, we need to learn the lessons. Yeah. Hopefully that answers.
Thank you, Scott. One question. What's stopping you to insulate your floor?
Yeah. Good question. Thought about it a lot. Should we go back to... yeah, you mean why doesn't the external insulation drop down over the ground floor? Yeah. Yeah, it could have done. We could have taken this extra skin all the way down. So 2 reasons. Firstly, we modelled it, and actually the benefit was not increased twofold by doing that, which was strange. So we think that is because...
Hot air rises. Because hot air rises?
Yeah, partly. Yeah, but also to do with occupation. And so we insulated in the cavity at ground floor, but we didn't take the skin all the way down. And I think it also comes back to the, you know, to the architecture of it. You know, we didn't want to obliterate the existing house either. So, you know, it was weighing up. But yeah, we ran the model, and also design-wise, broad strokes, drivers. We didn't want to completely lose the 1970s-ness, and we thought we would, for not as much benefit. So, yeah. But it's a good question. Yeah.
Scott, I was really interested by your observation about our changing expectations of the temperature in which we live. And perhaps that involves also kind of our expectations of it being different in different seasons and so on. And definitely the activity is part of it, but it is just purely, to a large extent, the fact that we now just, for some reason, expect to be warmer than we used to, which is odd when you think about it. And I wondered if that's another instance where we can maybe learn from traditional building types and Mongolian architecture in a way. And I wondered, you know, if what the expectations were in the past of those buildings in terms of the temperature in which you would be living, and if that has changed as well in the sort of modern city adaptations of the traditional form.
I think that's a really good link in how, yeah, the way we use a home has completely changed. So the yurt would be a flexible one space that was used as a breakfast room, a living room, a bedroom, a workspace, and it would consistently change as the hours of the day would change. And that meant everyone was always moving because you had to make space for other activities. And that probably meant that you could live with quite thin walls, whereas in the city, when they migrated, that use completely changed, and it made the structure very weak compared to when it was used as a mobile structure. And it meant that people who liked living in a yurt and had lots of well-being benefits actually it became very deteriorating and made the city one of the most polluted cities in the world. So I think how you use this space really affects how environmentally friendly it is, in the sense of humans are part of the operational energy. But that's, yeah. And in commercial, I think it's sad that we create spaces for tenants, especially in the high-end office market, to be the most comfortable. You know, you can control the temperature of the room to exactly how you want it, no matter the conditions inside or out, and that's what high-paying tenants want to have. So changing that mentality could be a good place to start.
Mm-hmm. Okay, thank you.
Look, thank you very much to both of you. But I just had a quick question. I met some young structural engineers the other night, and they were explaining that their education really doesn't include teaching of retrofit. So they're learning about, it's all about new build. So it's idealised structures, you know, and that's what you calculate on and all the rest of it, and which they both agreed was fine. But on the other hand, most of what they were doing, working on at the moment, were retrofit structures, which were much more complex and many more conflicting criteria, which was interesting, but it was something that they were not prepared for, because they imagined they'd just be somehow building all these new things. To what extent could we, in an education environment, change what we do to kind of promote the idea that this is not just a kind of add-on, it's not just a bit retro, not an addition, it's like actually that's very much should be central to the teaching of design, that actually a lot of the work we do is, you know.
Yeah, well, I think it is. I mean, if it hasn't already shifted, it's got to shift to retrofit is the norm. In a few exceptional situations, there is new build. But we've got to make that shift. I think, as far as teaching goes, you know, it throws up challenges because you've got to get to understand an existing property, haven't you? Mm. And that took me 2 years in this case. And you know, how do you do that? You know, you've got to you need to uncover things. There's something archaeological about it, and you've got to uncover layers. Really, in the professional sense, you've got to have a really good survey, maybe a 3D point cloud of an existing property to know what you're dealing with. So it's got a different set of challenges, but we need existing drawings, and students need to be able to get into the existing buildings. Like the site visit I did this week, I don't know if anybody's here in Hoxton. A few second years, you know, we got into this big old Victorian warehouse, and you know, you can feel the materials, you can get a sense of what you could leave and what you'd want to keep, what you'd want to change. But so it's a different. There are challenges as far as student projects go.
I always thought it was like learning to drive a manual car, whereas a new build always felt like automatic, because you would design something and then you'd go to site and be like, oh, I can't do that. And understanding that existing building, I think there's a lot of joy within it, and understanding why decisions were made, how people used it. It has this long history and this richness that I think a lot of cities have always existed within. And I think the word retrofit throws people off, but if you go to most cities and most buildings, there's so much, all of it is, especially churches, layers and layers and layers of changes. I think the future of architecture is definitely going to be that. So I think it is a good time to start looking at retrofit in education differently, and not seeing it as interior architecture or something that's very internal, because it evaluates the whole building. as architecture. So,
But the history aspect is something the students will be straight onto, because, you know, our students are really interested in all of that. But I think, you know, a studio brief would need to start with an existing building and a good set of existing drawings and access to getting into it. And I think that's how they'd all need to start. But students could research the history and latch onto certain things. Yeah.
and I think there's a lot of joy that comes from problem solving. So with the existing architecture, there's a lot of things that people may have not thought of originally that you can adapt and change. And solving those problems, especially in relation to accessibility, I think really is enriching and satisfactory, whereas I don't think you really get that from new build. But I think with new build, there's a lot more fear in what could go wrong in my idea of architecture and building. But
It's causing problems.
yeah.
Well, thanks very much. Thank you.
Okay, thank
you.
you.